A big round of applause for Plamen.
Thank you everyone. I was gonna ask, that light, it's mandatory to say, like...
If you want to look good on camera later on, yes. If you don't care...
Yeah, because I didn't manage to switch to light mode the presentation, but it's okay. What matters is what's gonna get spoken. So, hello everyone. My name is Plamen. I work as a DevSecOps engineer. I come from a DevOps background, but I pivoted my career into security, so I try to make my best to secure all this big landscape of DevOps tooling, software artifacts, build stuff, and you know, name it. So, are you ready to get enlightened by supply chain attacks and interesting topics? Because I will be bringing you insights on how you can do it yourself for free and basically improve your security posture overall. So let's wait for a second, people to come. Let me start with a quick poll. How many of you in your companies spend more than 50K a year on security, let's say, tooling or companies for security? Can you raise your hands? Okay, very little hands, though. You guys not doing security at all? Okay, so from the people that raised hands, can you verify cryptographically that the artifacts and software you produce is the software you claim it is, and that it comes from the source you claim it comes? You can verify it? Okay, we can chat later. The thing is, modern security companies provide something that I find inefficient, and actually I don't know why they don't solve the problem fully. You end up paying 5-6 figures a year, and you pay for basically an agent that scrapes your repos, your code, your registries, and it gives you just dashboards, fancy dashboards that your CISO watches, uses for reporting and all that. But can your customer use those dashboards to verify your artifacts? No. And that's where supply chain comes. It's the big problem, the elephant in the room. It's a hot topic. Year over year, the numbers are growing exponentially, and these numbers I'm showing you right now are fairly outdated because they are from last year, and they were growing by 75% year over year. So last year, there were $60 billion estimated losses to breaches that come from supply chain attacks. And expect the newest data to be like the triple of these numbers, because we're going to go through some of the latest supply chain attacks and situations. This one, old news, 2024. This one, old news, 2025. This one, old news, September 2025. Let's go with the one that's fairly recent, from February. So, supply chain, it's evolving, and it's using fairly enough of AI and leveraging your tokens. So we have this situation of hacker bot claw that attacked one of the biggest security companies out there, Aqua Security, and they owned Trivi. And the simple attack path was to ask Claude to look for vulnerabilities in their repos. And out of 9 vulnerability classes, it hit 5 out of 6 of their biggest repos, hitting the Trivi repo itself. It wiped their releases, so they lost their artifacts, and also force released every version to be a worm, basically, and to be a virus, let's say. The one survivor of the repos was because Claude said, hey, I'm not a bad person, I won't own this repo. And as an interesting fact, after reverse engineering their malware, it had a module inside called the Butlerian Jihad module, which comes from Dune, like the war against thinking machines. And it's just probing for every possible AI agent, like Cloud Code, Open Code, Kiro, Codex, and all that. And it's just saying, hey, just making sure you're here, respond with hello. And if there is an agent and responds to that, goes ahead and proceeds to persist itself into every possible configuration file for your AI agents, infecting effectively developer machines, build systems that for some reason are not ephemeral and have cloud, and skill servers and all that jazz. And that persistence gets saved as a commit made by Claude. So it's like, hey, you are committing with Claude, goes under the radar, nobody's reviewing that thing. And then you have the more novel supply chain example of this year and last year. It's Shai-Hulud. So this is the first self-replicating worm that's hitting DevOps and CI/CD environments, software lifecycle environments. And basically it started targeting popular packages of utilities, like who doesn't like colors on the terminal, right? On your test results and all that. Guess what? That's supply chain vector and possible entrance for hackers. So they started compromising by installing a post-install script that after you do npm install X package, just harvests your credentials from your machine. But then they did the second version, which they found out, okay, it's more effective to not run it as a post-install, but as a pre-install hook. And overall, they hit much more packages, much more popular than the previous ones. 132 million monthly downloads, 25K malicious GitHub repos, and the second version have this interesting dead man switch. If you don't have tokens that they can steal, it wipes your home. And then you have, from April, the third coming, which hit also LLM packages like Lightning. They started hitting more high-profile packages used by enterprise. They were targeting also Coinbase. And then another hit, the mini Shai-Hulud, which don't get confused or fooled by the name. This is like the most powerful one. Like it's hitting right now, I'm going to show you, which also gets installed as a pre-install hook, but it has different levels of persistence, and it looks for much juicier rewards, let's say. Here I have it. It hit even like last night for a 5th time. I didn't have time to update the presentation, but they hit more high-profile companies like SAP, Tanstack, Mistral, UiPath. Even though some of them have published their own researches with the findings, it may have affected or not. But the fact is that the worm spread and spreads fast. So it's a matter of incident response, not to take it lightly, let's say. So the mini Shai-Hulud, also it's worth mentioning that it hit repos and companies that have their supply chain taken care of. So they were publishing packages with secure methods, OpenID Connect, Trust, and so on. But the thing is, if it comes from a maintainer or a maintainer account, or with a typo-squatted email, or email that failed claiming the ownership, like the domain has expired, they claim the ownership, and they have infinite emails. So they can go and simulate maintainers to publish packages and so on. But before I go to the next slide, I want to show you, this is the attack from last night while we were partying. Team PCP hit again. Yeah, I'm going to zoom in. This is a search on GitHub for repos with this string. Niaga ok eo, if you read it backwards, is Shai Hulud. Here we go again. And it hit 2.9K repos, but when I woke up at 8 in the morning, this was 1.6. So it's growing, as you see, updated 2 minutes ago. It's spreading in real time right now, as we speak. Here we go. So yeah, the Shai Hulud fiesta, how this Shai Hulud spreads and what's the purpose, the target, how does it act? Basically, you have the bad guy that is scanning all over GitHub for your library, for SDKs, for popular packages, for used packages, and it tries to exfiltrate your tokens. After it exfiltrates your tokens, it tries to publish your own packages again, but it also targets packages that you provide to other people. So it spreads that way horizontally really well. But Team PCP, they are hackers that are for the money, right? So it's looking, as you can see in the goodies, it's looking for GitHub tokens, ECS credentials. It scrapes and enumerates your secret managers like Azure Key Vault, AWS Secret Manager, OAuth tokens. It gets whatever it can get his foothold on, and also lately looks a lot for possibility of spreading onto AI agents like LLMs. So it poisons hooks, poisons skills, and all that. And as an interesting fact, all the findings, all the tokens that his regex or tooling finds, they are validated on the spot. So whatever is exfiltrated, it's not just a regex of an old token, an expired token. No, everything is validated before exfiltrating. So the root causes are basically phishing or pretending to be a maintainer, stealing maintainer accounts, gaining maintainer trust, control handoffs of repos as well, and big CI/CD misconfigurations like the pull request target, which if you're not familiar, it's a GitHub Actions way of triggering a pipeline, but you trigger it from a fork and it uses the environment variables of the main repo. I don't know why they made that type of trigger and why somebody would use it, maybe to save time, but it's like a big door of, for hackers and supply chain. Like they are literally looking for repos with that kind of trigger. And when you think about it, what's the only way you can secure these root causes? Physical security, like passkeys, ephemeral tokens, rotations that are like daily or hourly or so on, and supply chain levels like Salsa, I will talk about in a bit, and hermetic builds and hash pinning. I will talk about in next slides as well about this. So what's Salsa? Salsa is a standard for supply chain security. Yeah, it's read like that. It's SLSA, but it's read Salsa. Supply chain levels for software artifacts. So this is a standard made like a video game that has different levels of, let's say, maturity in your organization or, let's say, build process, where the first level is just to generate a provenance. Sorry for the terminology. Supply chain has all these glossary thingies, but I will try to make it as digestible as possible. So provenance is just the record of your build process, like how the pipeline was executed, what was the inputs, what are the outputs, what are the dependencies, and how overall the software artifact is built. So the first level is just having this provenance, nothing else. The second level is having this provenance, but already having it signed by a CI system, ideally with an OpenID Connect token and not long-lived keys. The third level is having a hardened build platform, which means all these principles to be followed on your build platform. All these principles to be applied to every dependency on the build process, on your artifacts, and overall everything to be pinned down and secured in the best way possible. And level 4 is like aliens. I have heard about it, but I never seen it, which is hermetic reproducible builds, which means no internet, no dependencies, always producing the same checksum on the build, and basically having no inputs while building, right? And Salsa uses what they call in toto, which is a framework, basically a framework or a schema for JSON files that have these claims of what's being built, what's the signature of it, what are you claiming? You can claim everything, basically. You can attach those claims, we will see in a bit. So here you can see what's the end-to-end process and how these claims look like. So we start from the source. You have your own source, which you can install like a little seed, and every time you run your Salsa pipeline, it will know that the source is the one that you claim it is, like it's not tampered. You have your builder that does the provenance and that also get attested. Sorry, another glossary term, attest. This is when you make a document and attach it to your artifact, let's say your container image. So you do your provenance, you do your build, what went in, what came out. This is taken care of the provenance, and it gets attested as well. And you can attach as many artifacts as you want with claims. Let's say your test results, vulnerability results, I don't know, maintainer message. The important thing is to put as much of relevant to the artifact stuff, sign them, and ship them with your image or artifact. And then everything can be verified the opposite way around by your customers. We will see how is this in action. So why vendors don't solve this? They just give you a dashboard and call it a day. They say you're secure or you have these vulnerabilities, but they don't actually improve your software delivery process. What I have described now, and you will see specific tooling, it's absolutely free. So you don't have any trial to follow or money to pay. And also you have different choices. So don't take as written in stone that this tool is the only one that does certain things. You have different choices. Popular packages managers like NPM has been supporting Salsa since 2023. Homebrew also does, PyPy does as well. Maven started last year. So the important part of this is how do you sign, like the trust model. If you don't understand this part, this is where you are going to fail. Like, why couldn't you just make up a JSON? Like the hacker, he could just write a JSON that everything is verified and the provenance is good, right? What stops you from lying? It depends on how you sign things. This is the key. So the important thing is to sign it with keyless signing. You can use the SigStore library and framework, basically using OpenID Connect tokens for the signature, and the customer is going to trust not your company, he's going to trust your OpenID Connect provider. Like the customer is saying, I trust that the OpenID Connect of GitHub for my vendor, it's legit, right? But you have the other option, which is traditional keys with a private and a public key, but this is less secure and the whole responsibility of safeguarding the private keys on your end, which has been proven that you can get your private key stolen. It depends on your management of this. There's an example of Black Basta, which the people that were selling the certificates were selling your private key as well to hackers, which, yeah. So let's see it for real. This is a basic Java project I have, just a hello world. And I don't know if you can see, but basically we have the salsa provenance coming from GitHub with the builder ID, what workflow created this artifact, the URL, the commit, hashes, and so on. You have a SBOM as well, attested to the image with what components I'm importing, what libraries, what versions. You have the vulnerability scan also attached. You could attach VEX documents, for example, filtering part of this vulnerability scan. And the important part, the customer can do the reverse process with cosign. He can say, cosign verify that this container image comes from the GitHub repo it claims it comes from. Also, there is something called policy engines, which I have tested Ampel, which is also a very good project where you can define what type of policies you want to respect. Like, I can say that I only want containers that have all the test suite passed, or I can say I only accept containers that are signed, or I can have like 10 requirements, and Ampel takes care of fetching those records from what I have attested in the image. So they can manage this as code, manage their own policies, and verify before deploying, like your customer can verify. And here is a little screenshot of the attestations, how they look. It's nothing really exciting, just SHA hashes and describing what's in the image as bundled. For the inspection of this, I have used Bind. I will have like a glossary also of all these tools, so you can take a picture if you want to try them out at the end of the presentation. But even if you do all your due diligence, you still have spots that needs hardening. And this is lock your dependencies. Lock your dependencies hard with SHAs wherever it's possible. Treat log files as something that needs PR reviewing because it's important. Treat always your development environments as ephemeral environments and use OpenID Connect wherever is possible. Use trust on your cloud providers. Use the trusted method where GitHub trusts the cloud provider, not using tokens or path tokens and so on. And please, don't mix LLM stuff with your code. Don't put skills in the same place where you have your repos, because nobody is going to review 100 lines of markdown slop. So it's really easy to poison your agent, let's say. Also, you need to include static scanning in your CI/CD and infra stuff, and there are interesting libraries like Zsmore, which can prevent supply chain attacks in your workflows before them happening. Like, there are tools out there that can do what's called behavioral analysis in the pipeline itself, and it can stop it from happening, from publishing your own artifacts with viruses and so on. Also, your cache, treat it like secrets, because they can poison your cache and publish malicious packages through that scope. And scope. Scope every permission to what's really needed. Never use wildcards for anything, because the novel attack that I mentioned in the beginning that has the whole salsa thingy published malicious packages through a maintainer that got access to one package, but since the OpenID Connect token had in the scope a wildcard of all the packages of the company, he could publish the malicious packages through that gate. So always scope every permission to what's exactly needed. I invite you to get started and try it out with some small repo. Just add the provenance. You can use the Salsa GitHub generator. See the Salsa repo where they have different generators for container images, for Maven projects, for Golang projects, and so on. Create a provenance, see how it looks like, try to sign it with SigStore, try to attach it, to attest it to the image and ship it with it. At SBOM, start adding stuff and see how it goes. Because the challenge is that these attackers, they never sleep. They have all the time in the world to try out things, while you have just your narrow scope time that you are allowed to work. So use it wisely, sign stuff, attest stuff, and try to improve it the best you have. Here are the resources that I mentioned, all the tools that I have used in the demo. I don't know if it's easy for pictures, but anyway, in my last slide I have a QR code with all the slides, so you can check them, reference them, show them to your colleagues. Please spread the word. Salsa is important, supply chain is important, and it's better to talk about it now than talk it after you get wrecked and hackers publish packages on your name. Thank you for listening to my talk, and